Hello, everybody. This is Skylar Fishman. Just a reminder that you can find us on Twitter, Instagram, what's another? YouTube. So in this stream, I'm going to review population growth rate, which is kind of the nutshell of all of this. Brainstorm, we're going to brainstorm together factors that affect human population growth rates. We are going to define the total fertility rate and the replacement fertility rate. And having that definition kind of makes everything go click into place when you have that in your back pocket. So with those definitions, we'll do some example analyses of age structure diagrams. You guys ask a lot of questions. I don't want you to have to memorize these things. I want you to be able to look at them and remember and analyze. And then we'll do some practice. Okay, so 3.6 is age structure diagram. What does College Board expect us to do? First of all, it's that practice of explaining patterns and trends in the data to be able to draw conclusions. I mean, you're going to need that for environmental policy and law for sure. But being literate for APES and means you need to be able to draw conclusions and look at a lot of data, understand what's going on. What essential knowledge, the need to know, is that you can interpret the growth rate of a population from this age structure diagram. You can read this and gather that from its shape. A rapidly growing population, as a rule, will have a prior proportion of younger people compared to stable or declining populations. They want you to recognize this shape and what that shape means. So making the connection between these two is what we're trying to do. This is actually a map of the population growth rate. So 2% growth rate here in Africa, in North Africa, compared to a 0 or negative growth rate here in Russia. Does anyone hear background noise? I do not. Okay, our other objective is total fertility rate. Describe patterns and trends in the data again. And knowing that the total fertility rate, TFR, is affected by the age at which females have their first child. Educational opportunities for females, access to family planning, and government acts and policies. So this is a good one. Social services, public policy, law. Is that better? I could try unplugging my mic. I'm sorry for the technical difficulties. If I hold it here, do you hear me better, Tammy? Okay, I'm just going to hold it here. So if fertility rate is at replacement levels, think about replacement levels as a stable population, meaning the same amount of people are living and dying. So born and death, births and deaths equal each other. Factors associated with infant mortality rates, so the rate at which children survive or do not survive within their first year, include whether mothers have access to good health care and nutrition. Changes in these factors can lead to changes in infant mortality rates over time. So this is kind of like our human geography foray in APES, understanding how humans behave as a population, so that because that affects how they affect the environment. Okay, I see a question. We're going to get to that question in a minute. Okay, so again, we're linking and differentiating between populations, one with a high growth rate, one with a negative growth rate, and understanding the implications for that on fertility rate. So when you look at this, you should, at the end of this session, you should be able to go, oh, this is a below replacement rate. This is a 1.4 births per woman. That makes sense to me because that isn't enough to grow the population. And you should be able to make a connection between this shape and this total fertility rate, which is very high. It's way above the replacement rate. So just to review some things, you'll see we have our doubling time equation there. So somebody asked a question about doubling time. It's called the doubling time equation, and it's derived from this exponential equation right here. And we don't need to do all the math to do it, but if we said this is twice the starting population and we did all the math, it would just come out to be that really simple equation, which is the doubling time in years is 70% divided by the growth rate in percentage. So hopefully, does that answer your question? Yep, great. We'll do a little bit of practice with that. Okay. So all populations grow exponentially at their biotic potential. That's a vocabulary word you should be familiar with. Biotic potential is just technically, without any limiting factors, how would living things grow? For example, bacteria in a petri dish with all of the medium, all of the food that they need, they're going to grow exponentially at a rate dependent on how many eggs or how many times they can divide cells per second. Human populations grow exponentially depending on their growth rate, depending on those social factors. So the doubling time can be calculated from that growth rate. So for example, if we look at this and we see that, I think that's Congo. I don't mean to be ignorant of my African geography, but I am. Actually, let's say here Brazil has a 1% growth rate. What's the doubling time? Anybody want to take a guess? Yes, excellent, absolutely. Tammy said 70, perfect. If we're looking at a country in Africa with a 2% growth rate, what's the doubling time? Perfect. Oh, Dakota, wonderful. Yeah, it's simple. And after you do it a couple times and just keep that formula in your mind, it should be kind of at your fingertips. I like the doubling time as a way to think about population growth because I like to think about the fact that 70 years is somebody's lifetime. And the population of the Earth has doubled in my lifetime, which is fast. It's just crazy. Since I was in middle school to now, the population of the Earth has doubled. Right now, the population growth rate, I think, is 2.6 overall. So Congo right here has a 2% population growth rate, and it looks like their growth structure, sorry, bad. Their age structure looks like this. We're going to make that connection and see why it looks like that. So the question was, this is different from carrying capacity. The biotic potential is different from carrying capacity. The biotic potential is without any limiting factors. So the carrying capacity would be if this leveled off because there wasn't any more food, or there wasn't any more space, or there was predators, or there was a disease. That's the carrying capacity. The biotic potential is this green line. And then just a reminder that calculating the growth rate, getting to this map, you would need to know the births per year minus the deaths per year, plus immigration minus emigration per year over the total population times 100 to get a percent. And that is also an equation that should be at your fingertips. It's pretty intuitive, I think, but practicing with it and remembering the births add minus deaths take away. Immigrants add, emigrants take away. And then proceeding as a percent. Can I get a thumbs up if you've seen that equation before and feel like, oh, I could practice with that. I remember that. That's intuitive to some degree. Yay. Fantastic. Thanks, Tanya. All right. So brainstorming social factors. I mean, just thinking about it, what are the social factors that mean a woman is going to end up having 6 to 8 children versus a woman who chooses to have 2 children? What are the factors that affect her choices or maybe her lack of choices? And I've given you some ideas here. Yes, age, culture, peer pressure, exactly. Thinking like a social science. Education is huge. I wish I had that graph for you, and I might pull it up if I can get both hands and you can still hear me. But there is a graph. Look at the total fertility rate and the educational opportunities offered to women versus how many children these women have. You can see this is what kind of relationship? Positive, negative, more opportunities. There are many international programs that work in developing countries to provide microloans for women so they can start their own businesses. And when you tend to do that, the entire village will benefit. So if you're interested in international agricultural development, international development or international public policy is one really interesting topic, and looking at how to support developing cultures so that when women are at the head of those things, they tend to have less children, have a better life, and lower infant mortality. So infant mortality rate is a big determinant too. Traditionally, and this we'll get to this in demographic transition, traditionally, if you know that your children have a 50% chance of living past the first year, you're probably going to have a lot of children. If you don't have a lot of access to medical care, infant mortality is high, and those things are decisions and social factors, including religious beliefs as well, that even after infant mortality rate falls, women still end up having a lot of children. So let's get to some definitions, because I don't see a lot of questions right now. I think we're all on the same page so far. The total fertility rate is the average number of children that will be born to a woman over her lifetime. So if we're talking about the average fertility rate in a country, we take all the women in their lifetime, how many kids do they have, however long those kids live, and that's we average it out. It's the average fertility rate. The average number of children that each woman would have in her lifetime to keep the population stable. So if every single woman in her lifetime had children to replace her and her mate, that would replace the population, so that when her and her mate die, there are 2.1 children to replace them. So we call it the replacement fertility rate. Think about it as being stable. Stable, no population. If every country was at this replacement fertility rate, we'd have 0 population growth. Is there a world total fertility rate? Yeah, the world total fertility rate right now is 2.6. So it's above the replacement rate. So again, the total fertility rate is 2.1. Why do you think it's 2.1? Exactly, Tanya. In case someone dies, there are accidents that happen. There is, yeah, pretty much accidents, disease, cancer, things like that. We need to have a little bit more insurance than 2. So this is a magic number. This is something you want to memorize. Just think 2.1, mom and dad, or whatever family structure you're talking about, 2 parents need to have 2.1 kids on average. Life expectancy is the average lifespan of a population, or how long a person born in a country is expected to live. And life expectancy has been increasing, which is why we have overpopulation of people over age of 75 in this country and in a lot of developed countries. As countries gain more economic, status. People get better medical care. People live longer. So we have longer life expectancies. And that's a good thing. People want to have longer lives. Yes. Infant mortality, excellent question. The question was, is this all part of the Human Development Index? Yes. Life expectancy, infant mortality, total fertility rate is part of the Human Development Index, which you can look up on the CAA Fact Book, which is one of my favorite places to visit. And you can also look it up on the World Health Organization. So total fertility rate, as Tanya just brought up, is tied to development, social, religious, cultural factors. You should have some of those in your pocket. As we write FRQs on the upcoming AP, they may ask you to pull out some factors that may explain, why does this country have a total fertility rate of about 2.7? Or how would that 2.7 fertility rate tell you about some of the economic decisions that country would make? Or how would you recommend this country slow down its population growth and reduce its total fertility rate? And you want to think about some of those social science strategies. Why are these very human-related social science concepts part of APES? What do you guys think? We would need to know literacy rate. We would need to know literacy rate. I mean, I think you can sometimes imply that as part of Human Development Index, but what the AP is asking you to do is make some inferences about it, Tanya. So I think when we're talking about this kind of social science aspect of APES, they're wanting you to have a breadth of possibilities rather than answer the question as a sociologist would. Yes, Dakota, because it affects people on the planet. Absolutely. Yes, this part of human geography helps us understand why the resources that we have are being used where they are used, and understand where in the future it may become a problem. For example, Brazil, Amazon rainforest is threatened in part because of the huge population and growth and development that's happening in Brazil. So they need more land space for agriculture to feed all those people. So not all of world human geography. Yeah, not all of it, just this little part of it. IPAT, ecological impact, is population size times affluence, which means how rich they are, times the technology that country has. So that the impact of each country, population is a factor. Yes, exactly. So yeah, we need to know this. We're looking at a map here of the ecological footprint. So there's two ways we address the ecological impacts of human population. IPAT is one equation. The impact is equal to population times affluence times technology. So we have to understand how this population is changing. And then this shows ecological footprints, or consumption of biocapacity, which is that carrying capacity for humans. And you can see that some of these countries that had very high TFRs also are way over their biocapacity, not because they're affluent countries, but because their populations are growing so fast, in particular India. Whereas in the United States, our population is not growing very fast. Oh, no, that's a great question. The word affluence means how rich a person or a country is. To be affluent is to have excess income. To be affluent is to be rich. I would definitely put that vocabulary word in your pocket, although I'm struggling to find a easy way to remember it. It's just affluent. Ben Affleck is affluent. There's a good one. Sounds like influence. That's good too. All right, some good collaboration here. Money is influential. Yeah, that's better than Ben Affleck is affluent. All right. So let's do it. All right, so let's do it. Let's look at this age structure diagram. I'm going to try and ask you guys to do a little bit of I-squared, so identify and interpret. Let's identify first. What is on the x-axis? Gender for sure, right? It's interesting to us to look at males versus females, especially because TFR applies to females. Population number, right? And sometimes, and it's really important here for comparison, sometimes this will be a percentage, and sometimes this will be numbers. The shape should be pretty much the same, but sometimes it'll squish or be higher depending on whether this is percentage or population. And here we have age. All right, so 3 important ages: children, women of childbearing age, and the elderly. We care about children because they are the next generation that is going to reproduce and make more people. Women of childbearing age because TFR, and we care about the elderly because that is a financial and social strain on society because we need workers to support the elderly. All right. So in this graph, can you guys agree that if we drew this line, hold on, I'm going to get there. Where'd my line? There's the line. If we drew this line, and I would always draw that line, I'm sorry I didn't have it there to begin with, is these 3 important ages. When I see a graph, in order to interpret, I identify, yes, exactly. Yay. Okay. Rapid growth in this shape. And why? I care more about why than if you just recognize the shape, because you're more likely to remember it when you can derive it back yourself. So I draw this line on a graph if it's not already a different color, because I'm looking at this shape together kind of as a box, and I'm comparing it to this shape. So children are much greater than adults. Yes. All right, I like the comments. You guys are getting it for sure. So I know if children are greater than adults, this means that I'm going to have a TFR that's larger than the replacement rate. And indeed, does anyone remember what the replacement rate is? Type it in for us all. Yay, okay, it's there, way to go. So that means that we see this box is smaller than this box. That means these women are definitely having more. These women are having more than the replacement rate. And lo and behold, it's 2.8. Negative growth is called negative growth. So this shape that we found out by kind of cutting the triangle up into 3 parts, we found out that this shape means rapid growth. All right, so let's try it again. If we draw our imaginary line, yeah, that was positive growth. We don't really call it positive growth because growth is just growth. Negative growth is shrinking. We call it a shrinking population. Yeah, decreasing population or shrinking population. So to kind of go back to what we're going to do, again, shape 2, we want to, in our minds, because I don't know how to draw on the slides yet, kind of draw that line here, children, and then people of childbearing age, and then elderly people. And adults are greater than children, which means, anyone want to take a guess? Yes, Japan has a problem. They have a problem that is not a problem for their elderly because they're very happy to live a long life. This is a decreasing population and a low fertility rate. Ta-da! Yeah, you guys are totally getting this stuff. So the TFR, according to the World Health Organization, is 1.44, and that is that below the replacement rate? Yup. Yes, Gracie, that is below the replacement rate. Great job. And the population is shrinking. Yep, exactly right. All right. So far, How's everybody doing with this approach? Instead of just memorizing the shapes, we're kind of asking ourselves these questions. Let's do it again. What do you say? Oh, there's my bars. They came in last. All right. Here's the United States. That's an interesting shape, isn't it? So what's the first thing I want to do? I want to compare my children to my people of childbearing. Kind of draw those shapes. Again, pretty equal. Yep, they're pretty equal. The TFR is 1.8 for United States. So we would call this population stable, even though the replacement rate is slightly smaller. And you can kind of see this is decreasing here. It's a little complicated because here we're talking about the natural rate of increase when we look at this, assuming all these people here are born here and not coming here with children. And the demographic changes a little bit because actually the population in the United States is increasing because of immigration. So we would say this is a stable population. You can also sort of draw a straight line here between those two groups, or you could draw a straight line kind of in the average here. No, it doesn't, it is accurate, but it doesn't match the TFR exactly. The TFR would imply that the population is shrinking a little bit. Yeah, that would have been a good question for the ask a question, so so like people can come back to it. But I think we handled it. When you see something that's straight up and down like this, even though this TFR would say that the United States is shrinking slightly, we can look at this and say with confidence, this is a stable population, especially compared to that shape, right? Or compared to that shape, which is rapid growth, right? They look really different when we go through them. When we do that, it's very clear. I don't know. I'm holding the mic. I do not have it. It may just be my keyboard. We'll definitely take the feedback and get a better mic. All right. So how to lower TFR? Is the mic. I'm just going to get a better one next time. Family planning. I bet you guys can come up with these ideas before I can. Family planning. I'm sure you can come up with them before I do even. See if you have them in your back pocket. So I say to you like, my country on another planet is having super rapid growth and we're going to run out of food. What am I going to do? Exactly. There we go. More jobs, help with finances. That's a factor. Yep. Contraception. Yes. Access to contraception, access to free medical care, birth control. For example, public awareness campaigns can really help. In Brazil, they involve the clergy to help people change their ideas. Access to abortion, absolutely. Okay. So, for example, the two age structure diagrams show Brazil in 1970 before social policies were enacted, and then Brazil in 2020. They even had a soap opera campaign where like the most popular telenovela like focused on like women choosing to have less children and like changing their lives for the better because of it and making those choices with the help of their clergy. Educate men, yes, I like it. All right, so which is which? I had an A and a B. Which one do you think is before 2020? Which one's 1970? Which one is 2020? I'm giving it away. Absolutely. And I think it's important to be able to say, you know, why. Yep, exactly, Tanya. Tammy's got it. Yep. I should have held out a little bit longer, but made it a little bit harder. You guys totally have this. So I think it's important that you can identify it and say why. Why does this shape tell you of this first graph tell you it's got to be 1970 when they had rapid population growth? Not just that it is, but again, get back to those two shapes. What's true about the children here compared to the people of childbearing age? Exactly. Tammy's got it. So being able to talk about the shape and explain your analysis shows that you're fluent in that practice. That we're not just memorizing, and memorizing is important, being able to recognize it is important, but that we can explain our analysis. We can look at this and draw a conclusion. We can say growth, why growth? Growth because. Exactly. Right. We want the reasoning, and beyond the no, you have the evidence, not the reasoning. We want the reasoning talking about the evidence. So the evidence is here, there were way more higher percentage of the population were children than were the people having children, which means those people were having a TFR of more than, somebody type it, the TFR here is more than, yes, Gracie, excellent, right. Looking at those two shapes, we can infer the TFR is higher than 2.1, which means we're going to have growth. Looking at this, we see a stable or even shrinking population. Why? Somebody want to work on their writing skills? Equal percentage of children to adults, or slightly smaller even. Fantastic. Yep, and it's that level of detail that shows you are able to analyze TFR, analyze age structure diagrams and infer TFR and make that connection. So age structure changes over time. Let's just watch this for a minute. What do you see happening? Thank you. Okay, we have some good observations. More adults. And then as time goes on, leveling out. Yeah, leveling out. I guess we can call it leveling out, even though it's kind of horizontaling out, right? The population growth. China is decreasing in TFR because of policies, exactly. So in 1979, China enacted the one-child policy to slow its population growth. Okay. Now we can see it a little bit better. Sorry if that's blurry. It's not getting any better. This is a prediction, Tanya. Yes. So it's a prediction into the future. And of course, where are they shifting? They're shifting what direction? Up or down? Yeah. So this is a prediction based on TFR as it is now and policies going into the future. But you can see India used to be this shape that was definitely positive growth, and how it's leveling out because of policies and development. All right, I'd like to get to some more of the practice, so I'm going to read you the slides and kind of take your questions as well. You can see the general shape in this GIF moving. Do you think India's TFR is predicted to rise or fall in the future? What do you guys think? Okay, well, right when we start in 2000s, India's TFR is really high, right? Right now, I think it's about 5.6, or it might have fallen to 4.8 recently. So when we first start looking at that pyramid, it's super high growth. But then you see how it flattens out. They are reaching the next stage of the demographic transition. They are going from pre-industrial to industrial. But you see, by 2050, this line is straight up and down, which means that by 2050, we're thinking that they're going to be around 2.1. And there's a lot of policies and projections about why that would be. China has had too much success with its one-child policy, and now they have this huge elderly population with nobody to work, and they have more men than women, and so they've reversed their one-child policy because it worked too well. So you should definitely, if you're interested in this stuff or you want to review it, you should definitely go check out the demographic transition. Oh, yeah. Okay, culture requires parents to have one boy and one girl. Interesting. It's a projection. I think looking back at that slide, part of the reason why I wanted you to see that is not because it's necessarily what's going to happen, but that you understand that that population pyramid shifts up. However big that population of children are is generally how big the population in 10 or 20 years of childbearing age will be. And so you can imagine that it shifts up. Oh, okay. Interesting. I really wish this wasn't fuzzy, but I don't know what to do about it. Age structure diagrams have shown a progression for countries, so you can kind of see the shapes. And if you grab the slides in the resource section, you can see we go from high infant mortality in pre-industrial to that pyramid where we saw that lower section in industrializing, where we have rapid growth, to starting to stabilize, slower growth where that line gets straight, to stable, and then sometimes to shrinking. Yes, it is birth and death rate. So you can see that what's happening in some of these countries where we see very rapid increase is a high birth rate, but a falling death rate because of medicine, because of job opportunities, because of education. As a country develops wealth, they're able to lower their infant mortality rate, lower their death rate, but social factors do not change for a very long time because these are changing people's minds. This is better sanitation, running water, hot water, electricity, medical clinics. And this falls, making this pyramid shape start to flatten out. But there's this population momentum because it takes time to culturally shift those choices that women are going to make. All right. You can see sanitation has to do with health. Yes, totally. And sanitation is a big issue in developing countries. Running water, flush toilets, electricity, heat, shelter, they're limiting factors for humans as well. And so without sanitation, you're going to have a higher infant mortality rate. These are great questions. So let's see if you got the gist. You can see the shapes are kind of blurry, or if you have the slides, great, good. So which one of these countries has the largest population growth rate, A, B, or C? Yup. I should say 1, 2, 3, go or something. All right. Which of these countries has the highest total fertility rate? Yup. Well, okay, Dakota said B. Remember, we have to compare. It's per woman. So when we compare this shape here in B, it's not that much smaller than the children. Comparing the children to the people having the children, these are pretty close to each other. It's just a large population. Whereas when we compare these people having children to the amount of children, yes, the correct answer is, drum roll please, you can't drum roll please, is A. It's A and A. Yep, A and A. Yep, don't be thrown off by B. Look at how we have some vertical lines that are almost straight between these 15, 25, 20, 15-year-olds. They're not that different. And look at the women, right? And these are percentages. Oh no, they're population in millions. Which of these countries has the lowest infant mortality rate? And you would have to infer this by analyzing the graph, the lowest infant mortality rate. Let's see. Tanya's coming in at C. Gracie's coming in at C. Yep, it's C. And so I want to correct something Tanya wrote. This is not necessarily pre-industrial. It is almost pre-industrial, but it's really transitioning. Pre-industrial, you'd see a huge gap right here between children and adults. You would see way skinnier even, right? Because pre-industrial is huge amounts of infant mortality, and people have lots of children, high birth rate, high death rate. This is not really pre, this is transition. This is industrializing, still somewhat of a peak, but it's industrializing. Remember, there's that population momentum, and this one is post-industrial. C is post-industrial. Developed, yeah, or we would say post. And I think you'll get some really good review on that. Keep in mind there's that population momentum, and keep in mind the top is always going to be a peak because eventually people got to die, right? People get older, and so you're always going to see a smaller population of elderly. They're not going to be straight up and down, and then all of a sudden everybody dies at the same time. So what could country A do to reduce the birth rate and have its age structure diagram look more like B? Yes, that's right. Immortality does not exist. Education, contraception, absolutely. You could also write family planning, which involves more than just contraception, involves healthcare access to abortion, absolutely. And with education, you want to get more specific. I mean, think about also people's religious beliefs as well. Economic support, exactly. It may not have a large enough workforce to support the entire population because there's so many people past retirement age. We're somewhat in that situation in the United States as well. And it's part of the reason why, like right now, Florida is a huge hotspot, is we have a huge amount, less taxes that as well. Yeah, exactly. You guys are really good at breaking these details down. And I know in a free response, you'll get into the details there. Yep, exactly. This is actually China as well. And oh no, it's not China. Sorry, I lied. But when you look at China's, so there's this great site called populationpyramids.net. And if you look at China's, you'll notice something right away, which is, I don't know, do you notice it? It's a little bit harder to see on this because it's percentage and you'd have to see it on your own screen. But there are way too many men compared to women at this age. There's not enough women to marry the men. 5.7 versus 5.2. So just an example FRQ is in the slides for you to practice with, and kind of linking it back to our environmental consequences. This is a 2017 released FRQ, and I think it'd be good for you to practice it and see if you got our objectives for today's lesson. I don't know how many of you have. Oh yeah, Tanya's sanitation. Gracie's right. I don't know if you have access to these slides, but you can also just Google 2017 FRQ questions AP exam, and you can also look at the scoring guidelines. And this is asking you to connect these ideas to the environment. So they're giving you fertility rate. In 1995, it was 5.2 for Haiti, and in 2015, it was 2.7. So what happened to population growth? Okay. Is it because you can't see the slides? Oh, okay. So I'm asking you guys, we're looking at this FRQ. I'm really sorry it's blurry. But it's a good FRQ because it makes the link between the environment and deforestation and population growth. And so Haiti was going through severe deforestation in the late 90s when they had a fertility rate of 5.2. And then in 2015, they had a fertility rate of 2.7. So what does that mean when the fertility rate dropped like that? What was going on with population growth? Yeah, so the population growth slowed down or decreased. And what else could you say about Haiti in 1995 if their fertility rate was 5.2? Economically, what was happening to that country? So it went closer to the replacement fertility rate, RFR. Yes. So, but before that, in 1995, would you say they were developing? Would you say they were transitional? Would you say they were developed? Would you say they were very economically, yes, transitional? Would you say they were a rich country? Poor country, right. So the question asks about one reason why deforestation commonly occurs in less developed countries. Yeah, it was a huge fertility rate. Yeah, they need the land. They also need the money, right? They're going to sell that lumber. They're going to ship it overseas. This is true in Brazil, or they need the land for agriculture and for the growth of the people. Great. These would all be appropriate answers if you like built them out into like 2 or 3 sentences. I can see your thinking. Yes, sell lumber, use land needed. They need the resource. They need those provisional ecosystem services. And then it asks you to develop one realistic strategy to reduce deforestation in a less developed country. So now you need to start thinking about what are the economic needs of that country? How could you fulfill those needs? And offering concessions for them to preserve their land internationally would be one strategy. Another strategy would be to find ecologically sustainable ways to use that lumber, but also to address the economic needs of that country. And then they ask you to identify and discuss one factor in a less developed country that could contribute significantly to a change in life expectancy, because the life expectancy also increased. And we talked about those social factors. And then they want you to identify and discuss one economic or cultural factor that could contribute significantly to a change in fertility rate, similar to what occurred. Yes, 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 yes. Teachers, yay. And so before we go, these are kind of the three major shapes you should expect to see. It seems like you're really good at recognizing them and kind of pulling out those social factors out of your pocket. Do you have any other questions for me? More practice. I would say a great way to practice is to go to population pyramids and look at the shape there, and then look up the TFR. That would be a really great way to make practice. Or go to the CIA fact book and look up people and look up the population. They also have the population pyramids on these pages, and you can kind of link that demographic data and practice for yourself. You can also look up FRQ examples for APES. There's 2 or 3 that are like this. And 2017 is one, 2014 is another. The other ones ask to do math and graphing, and I don't think they're going to ask you to do math. I don't know. They could ask you to do the math. But I think making these connections between total fertility rate and those social factors, and most importantly, Unit 5, like how population affects the environment. So I think this question's a really good one. I think, yes, have a calculator handy, but I think more importantly, can you describe and discuss the implications of that TFR? If they give you TFR that's 7.8, then can you infer the environmental implications for land use, for deforestation, for agriculture, things like that, making those connections. So that was, yeah, someone said, would it be too much to hope for the FRQ? I don't think it's too much to hope for, but I mean, I think it'd be wonderful because most students really have something important to say about it. So let's hope, but be prepared to make that connection. And remember to divide that shape into 3. Yep. All right. Well, thanks a lot, everybody. My first live stream on Fiveable. You guys have been really helpful and wonderful. Thank you very much. Tanya, you're so nice. Okay, bye.